2-6, we're going to look at imaginary numbers, which are kind of cool. Basically, people just didn't know what to do with something, so they made up numbers to solve them. And it turned out that they worked mathematically, so they kept them. And it will also introduce complex numbers as well, which is actually pretty simple. The concept of what we're going to do is a little bit confusing, but the actual math is, I think, very easy. So it says, so far in this course, you've been working with a set of numbers that includes 0, all positive and negative rational numbers, such as 999, -2, 237, 238, all positive and negative irrational numbers. Remember, numbers that you can't make an easy ratio. They go on forever without repeating or terminating. So square root of -2 and pi. These are known as real numbers. So, however, you have not been able to solve some quadratic expressions like x squared equals -4 because there's no real numbers that you can square to get a negative answer. To solve this issue, mathematicians created a new expanded number system based on new number. This was not the first time mathematicians invented new numbers. To read about other such inventions, refer to the historical note that follows problems 5.126. So in this lesson you will learn about imaginary numbers and how you can use them to solve equations that were previously unable to solve. So consider x squared equals 2. When you solve x squared equals 2, how many solutions should you get? You should actually get 2 solutions when you solve x squared equals 2, oddly enough. There should be a positive 1 and a negative 1. It says how many x-intercepts does the graph of x squared minus 2 have? So let's take a look. So let's say y equals x squared minus 2. And you can see it has 2 solutions, right around 1.41 and -1.41, right? So it says solve the equations x squared equals 2 and write your equations both in the exact form and the decimal approximations. Well, that's what we're actually going to get. We're going to get plus or minus the square root of 2. Those are going to be the exact form, and the decimal approximations are going to be plus or minus 1.41, right? We just saw that right over here in Desmos. I will say the precise answers, you get to use the equal sign. These are going to be about the approximation. So people don't like square roots. They prefer decimals, at least at the beginning. But I think the further you come along in math, you understand how much better fractions and square roots are rather than decimal approximations. So I think you'll notice as you move into integrated 3 and hopefully beyond that you find yourself using more and more precise notation. Anyway, it says mathematicians throughout history have resisted the idea that some equations may not be solvable. Still, it makes sense that x squared plus 1 equals 0 can't be solved because the graph of x squared plus 1 has no x-intercepts. So let's take a look at that. You can see it doesn't cross. There's no solutions here, at least no real solutions. There's going to turn out to be imaginary solutions that they came up with. So it says, what happens when you try and solve x squared plus 1? Well, when we equals 0. When we try and solve x squared plus 1 equals 0, we get this. And we have to take the square root of a negative. And we resist that, right? A negative times a negative equals a positive, so how can we get that? Well, in 1500s, an Italian mathematician named Raphael the Bomb Bombelli, clever, right, invented an imaginary number, the square root of -1, which is now called I, because I can be defined to be the square root of -1. It follows that I squared equals -1. So let's talk about this real quickly before we jump too much into problem 5.126. So I, and what it does and kind of how it came into being here. So I will say that I is the square root of -1, right? And essentially it's nothing more than I to the first power. Actually, let's change this. I want to change this. I will say that I to the first power is the square root of -1, and it just equals I. So what if I have I squared? What's the square root of -1 times the square root of -1? And the square root of -1 times square root of -1 equals -1. What if I have I to the third? Well, think about it. I have the square root of -1 times the square root of -1 times the square root of -1. Well, I already know that the square root of negative 1 times the square root of negative 1 equals negative 1 times, right, the square root of negative 1. So I'm actually going to get a negative square root of negative 1. Well, the square root of negative 1 is I, so I'm going to get a negative I, right? Kind of weird. What if I go I to the 4th? Well, I already know that I'm going to get the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. This is going to equal negative 1. This is going to equal negative 1. And what's a negative 1 times a negative 1 equal? It equals a positive 1. Now, what if I want I to the 5th? Well, again, and I know this is kind of confusing, but hopefully, because it's a video, you can rewatch it if necessary. So I have 5 negative 1s. Well, think about it. The first 4, I already know they equaled 1. So really, I'm just saying it's 1 times the square root of negative 1. And the square root of negative 1 we know equals I. So I'm just going to get this pattern repeating, right? I just keep going back and forth. I, negative 1, negative I, 1. I, negative 1, negative I, 1. So you keep getting this repeating pattern. So what will happen is when you're taking the SAT or doing your SAT prep, you'll get a question that says something like I to the 47th power equals what? Right? And it seems like it's kind of a weird question, but every 4th time we just keep getting this pattern, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 28, 32, 36, 40, 44, 45, 46, 47. So it must equal negative I. So it's kind of a trick question, just getting, do you understand that pattern of I and what it does? So you'll be talking about this probably more in Integrated 3, but I just wanted to throw it out there in case you guys do some SAT prep or anything along those lines. So what do we get here? Let's just kind of jump into this. The definition of I and rewrite each of these. Well, I know that this is going to equal negative 1. The square root of negative 1 times the square root of 4, right? Isn't that... Actually, I think it's going to be better. Isn't the square root of negative 4 basically the square root of 4 times the square root of negative 1? I think this will make it better. Well, we know the square root of 4 is plus or minus 2, and we know the square root of negative 1 is I. So there's our answer right there. Right? Let's simplify this. 2 times 3 equals 6. I times I is I squared. I know that I squared equals negative 1, so I'm going to get a negative 6. Again, I know that this can be really confusing. We're not getting a ton of examples here. This is more of an introduction than anything else. All right, here I'm going to get a negative 5 times 2i times 2i, right? That's what the saying, this 2i is squared. So I'm going to get negative 5 times 4 times I squared. So I'm going to get negative 20 times I squared is negative 1, so I'm going to get a positive 20. And then here, I know that the square root of 25 is going to be the square root of 25 times the square root of negative 1. That's going to be plus or minus 5, and that's going to be I. So again, just a few examples to sort of run through. Kind of crazy, kind of tricky. Not the worst thing in the world. You'll spend more time with this later. Let me pause and keep going. Context, imaginary numbers. In some ways, each person's math education parallels the history of mathematical discovery. When you were much younger, if you were asked how many times does 3 go into 8, or what is 8 divided by 3, you might have said 3 doesn't go into 8. Then you learned that numbers other than whole numbers, and the question had an answer. Later, if you were asked what number squared equals 5, you might have said no number squared equals 5. Then you learned about irrational numbers. So similarly, about 500 years ago, the answer, what's number squared equals negative 1, was no number squared equals negative 1. Then something remarkable happened. The mathematician Bombelli used a formula for finding roots of polynomials. Within the formula was the square root. When he applied the formula, the number under the square root came out negative. Instead of giving up, he had a brilliant idea. He had already figured out that the equation had a solution, so he decided to see what would happen if he pretended there was a number that could square to make a negative. Remarkably, he was able to continue the calculation, and eventually the imaginary number disappeared from the solution. More importantly, the resulting answer worked. It solved his original equation. This led to the acceptance of imaginary numbers. The name stuck. The mathematicians became convinced that all quadratic equations do have solutions. Of course, in some situations, you may only be interested in real number solutions, that is, solutions not having an imaginary part. All right, so it says graph this in our calculator. X squared minus 4x plus 5. X squared minus 4x plus 5. You can see it has no real solutions, so this is going to end up having imaginary solutions. Use your new understanding of imaginary numbers to rewrite your solution using I. Do not, and not the square root number. So essentially what this is saying is, let's go here and let's use some good old-fashioned quadratic formula, right? So that's going to be negative b plus or minus the square root of b squared minus 4ac. All of it is going to be over 2a. So my a is 1, my b is negative 4, and my c is 5. So I'm going to get a negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 5. All of that is going to be over 2 times 1. So I will get negative is 4 plus or minus the square root of 16 minus 20 over 2. So I'm going to get 4 plus or minus the square root of negative 4 over 2. Well, we now know how to deal with this. 4 plus the square root of negative 4 over 2, and 4 minus the square root of negative 4 over 2. I know that I'm going to get 4 plus 2i over 2, and I'm going to get 4 minus 2i over 2. I can simplify and get 2 plus I and 2 minus I, right? Those simplify there. So this is what we're going to end up with, and this is known as a complex number. A complex number means that there's a real part and an imaginary part. Lesson just sort of has us go with these complex numbers, and again, it just sort of shows that they exist, and we've already shown that they exist, so we're fine with that. But what we do want to do is figure out how do we add and multiply, subtract these things. So we're going to do a couple of examples and then call it quits on this video. We combine these things, right? How do we add complex numbers? So it's really just like adding and subtracting variables. The rules are the same. So 8i plus negative 4 minus 8i minus 7i. Well, 8i minus 8i cancels out, so I'm just going to have negative 4 minus 7i. So it really follows the same rule of combining like terms. I can add i's together, but I can't add whole numbers together. So, and sometimes we need to distribute. So 3i plus 2 minus 8 plus 5i. So I'm going to get, and by the way, be real careful when we're adding versus multiplying. There's going to be a difference. By the way, you should do the real part first. So 2 minus 8 is negative 6. 3i plus 5i is going to be 8i. Now, if we continue along, we've already dealt with these, right? So now we're just going to do area models, but now we're going to have negatives. So 7 minus 7i and 4 minus 3i. So be real careful. 7 times 4 is 28. Here I'm going to get negative 28i. Here I'm going to get negative 21i. This is going to be tricky. A negative times a negative is positive. 7 times 3 is 21. I times I is negative 1. So this actually equals, if I rewrite this whole thing, I'm going to get 28 here, negative 28i here, negative 21i here. This is going to be negative 1 times 21. This is actually negative 21. So when I combine, I'm going to get 7 minus 49i. So kind of tricky. And again, you want to be real careful with those rules. So let's do one more of these things and then turn you guys loose. So on this one, I will say negative 2, negative 5i, negative 1, negative 8i. A negative times a negative is a positive 2. A negative times a negative is a positive 16i. A negative times a negative is a positive 5i. A negative times a negative is a positive. 8 times 5 is 40. A negative times a negative, I'm sorry, an I times an I is a negative 1. So I'm going to get negative 38 plus 21i. So kind of interesting. Obviously, we spent more time in class on this, but that is the gist.